It's a very good morning to you, viewers, and thank you so much for joining us. We have interrupted normal programming to bring to you this special coverage of the deployment of Zimbabwe's first satellite, the ZIMSAT-1, that will be taking place this morning in Japan. My name is Justin Mahlahla. Now, of course, today the world will witness the deployment of Zimbabwe's first ever satellite, the ZIMSAT-1, which was successfully launched into the International Space Station on the 7th of November 2022. Of course, today being a very special day, as that nano satellite will now be deployed to make sure that it performs its functions and also to ensure that the country starts to reap the fruits of that deployment of the ZIMSAT-1 into the International Space Station. Now, the rocket carrying the tiny satellite was successfully launched from Virginia in the United States alongside Uganda's own first satellite. We are now crossing over to Japan, where we are joining our engineers there. They will also be giving us updates from that end as the deployment takes place. Let's follow proceedings from Japan.
Nigeria, Bangladesh, Malaysia, Bhutan, フィリピン、スリランカ、ネパール、パラグアイが参加しております。外国人学生は本学の修士課程あるいは博士課程の学生として入学し、その在学期間中に衛星の設計、製造、運用までを経験します。そして卒業後に母国に戻り、宇宙エンジニアとしてその国の宇宙産業発展に貢献することがこのプログラムの目的です。また、それぞれの国に衛星の地上局を設置し、日本上空だけでなく世界中で衛星を監視運用できるバースグラウンドステーションネットワークの構築も行っており、今回のバース5衛星についても各国に設置してある地上局にて衛星電波受信を試みます。今回はバース5ということで、バースプログラムとして5世代目の衛星になります。今回の参加国はジンバブエとウガンダです。両国とも国として初となる衛星です。世界の超小型衛星の打ち上げ台数は年々増加しており、スターリンクなどのメガコンステレーション企業を除いた数でも年間300機を超えております。本学は運用する小型、超小型衛星の数において、大学学術機関の中で2018年より4年連続で世界1位となっており、小型衛星分野で世界をリードする大学となっております。これにて娘の本プロジェクト概要を終了いたします。続きまして、本プロジェクトマネージャーのビクターより本プロジェクトについてご説明いたします。日本語では私が後ほど発表いたします。Next, we will hear an explanation of VARS5 project by project manager Victor Mutungurwa.
Okay, thank you, Oshiro-san. Greetings to you all, the people of Japan, the people of Uganda, and the people of Zimbabwe. My name is Victor Mkungunogwa. I'm the project manager for BEDS5, which is a project where we're developing the first satellite for Uganda and Zimbabwe. And also we were having the Taka satellite, which is for Japan. Today, it is indeed a sensational duration to stand in front of you today as I present to you the BEDS5 project, which we have Uganda and Zimbabwe as participating nation, and the host nation is Japan. The BEDS program, where Japan is hosting, seeks to give a technological transfer for building satellite for non-spacefaring countries. And in the BEDS5 project, we had the three stated nations as shown on the slide. And at the bottom of the slides, you can see those are the names for the satellites that were built, the Pure Africa Sat-1 for Uganda, Taka for Japan, and then ZIMSAT-1 for Zimbabwe. To make this project a success, we were sponsored by the government of Uganda, Japan, and Zimbabwe. They were sponsoring the building of the individual satellite. And then we had other collaborators that include the JAXA, the ISAS, the Ministry of Science and Technology and Innovation of Uganda, and the Zimbabwe National Geospatial and Space Agency. And all these activities were being done at the Kyushu Institute of Technology, which is QTech. And we had allied students from Morocco and Trinidad and Tobago. Going on to the timelines for the deployment today. Just before the satellites are deployed from the International Space Station at T0, the satellites are currently off. And at T0, after deployment, the electrical power systems, which is the EPS, is going to engage to close the deployment switches, which will trigger the EPS to start charging, and then the OPC will turn on after T0 time, and then there is collection of telemetry data. Initially, after deployment, the satellite will start to detumble due to the passive system, which it is the attitude control system for the satellite. Then 31 minutes after deployment, we'll see the antenna deployment, and then we expect to start receiving the CW. Going on to the introduction of our team, this is the project instructor, Professor Cho, at the middle, and we had other participating nations and other professors, and some are not displayed in this picture. We also have the PINO mission that is on the Taka satellite, which is a 2U satellite, and the PINO mission is a project for JAXA, and these are the JAXA members that are on the project. Then, as you can see on the slide, this is the BEDS 5 logo. We have, for Japan, Uganda, and Zimbabwe, we have our national bird. So that bird is a unifying bird for all, symbolizing all our national birds that are flying in space. And we have the CubeSat that is made out of the flag for Japan, Uganda, and Zimbabwe. And the stars represents the PINO mission. And the green for Africa and other continents is the land use and cover mission that we have for the bedside satellite. And then the blue, which represents the water, is the water quality mission that we have on the BEDS 5. We have the white star, which represents the unknown mission. We have other missions that we are going to do that are not listed in this. We limited the scope of the project, but a lot can be done. And at the bottom, those are the entire satellites to be launched today, to be released today. Going on to the general view for the satellite, on the left we have the 1U CubeSat, which is the same satellite, but which is the same satellite designed for Uganda and Zimbabwe. They host multispectral camera, both the satellites for Uganda and Zimbabwe, and also they have the RGB camera, which will take visible pictures. And on the 2U, we have the PINO mission, which is for JAXA. So those are the main differences between the satellites. The internal view, as you can see on the slides, we have different PCB boards arranged in the satellites, and each satellite houses 3 cameras, and also they have different spectrum bands for each and every camera. Going in detail how the boards are arranged internally inside the structure. As you can see, this is the BEDS 5 satellite 1U, and we have various boards. It uses the standard bus system for QTech, and we have other mission boards that are stuck within the satellite. Missions. The BEDS-5 mission houses the multispectral camera, which is made by the BEDS-5 project and using commercial off-the-shelf components. And the multispectral camera is meant to use the land use and cover mission, which is mainly to promote agriculture in the host nations. For example, harvest estimations, monitoring of crop health, among other land use and cover missions and surveys that can be done. This is with the aim to promote agriculture in mainly Zimbabwe and Uganda. And also we have, and this is to achieve the sustainable goal number 6, which is food security. Then the other multispectral mission is the water quality assessment. The BEDS-5 satellite seeks to survey the water bodies in Zimbabwe, Uganda, and Japan to see sources of contamination and eliminate the source of contamination at the source. This will, to a great extent, minimize the amount of chemicals used to purify drinking water. This mission is meant to achieve the Sustainable Goal Development number 6, which is the access to clean water. Then we have soil fertility assessment, which is meant to support the agricultural activities and mapping the fertility of the soil. This will optimize the distribution of agricultural inputs to various agricultural regions in Uganda, Zimbabwe, and this is the other mission for the multispectral mission. Going on to the next mission, we have on the mission board 2, we have the image, we have other missions such as the image classification. The image classification uses a camera that sees in the red, green, and blue spectrums. It's generally for mapping, that is generating maps from space for our individual countries. Then we have the automatic packet reporting system, or DHPTA mission, which is meant to serve the amateur radio community in the times of disasters, to give communication in the times of disasters. BEDS-5 also have the passive attitude determination and control system, which is a new design that we're going to test on this satellite, to which controls and orient the satellite in the correct regime during operation. Going on to the next mission, we have the APR, the store and forward mission, which relays data from ground sensor terminals to the control station, which is the ground station. For Ugandan ground station, they can receive any data. For Zimbabwe and Uganda ground station, they can receive any data from anywhere, even the remote areas across the globe, to receive data at the control station. This mission is meant to monitor disasters and also help to solve the landslide issue by creating ground sensors which sense landslides, and also monitoring of cyclones and flooding, among other disasters. The store and forward mission also is meant to do the solar illumination mapping, which is a problem currently in both Uganda and Zimbabwe, to solve the electricity problem. The solar illumination maps the regions where there is high solar intensity, and thereby optimizing the deployment of solar farms in Uganda and Zimbabwe and solve the electricity distribution. This is how the satellite, space satellite, will contribute. Then we have the data transmission communication to remote areas. These are ground-based sensors that are mounted, as I have mentioned before, on the ground to transmit weather data and among any other data that can be transmitted via the satellite and to the ground control station. Then going on to the other mission, the BEDS 5 team developed the BEDS Nest application. The BEDS Nest application is a mobile application that is used to track satellites, and this application is ready now on both iOS and Android devices. You can download it now. However, it is important to know that this application will be efficiently working in 2 weeks after the satellite data has been downloaded and installed in the application to enable tracking of the satellite. But for Android and iOS device, it is ready to download this on your devices now to see our satellite, and you can interface to see the satellite structure and see the images that are captured for outreach purposes only. Then other images, they are not accessible to this business application. We also have the attitude determination and control system, which is meant to predict the camera pointing on the satellite, to point on the ground to see how the satellite is pointing to the ground, like to water bodies or to farms or different agricultural lands that are of interest. With this attitude visualization mission is meant to support both the multispectral camera mainly and the RGB camera. Then we have the patrol instrument for nanosatellite PINO, which is a JAXA mission that is only on the Taka, that is meant to measure the high precipitation of ions in space, and this mission was hosted by JAXA and ISA's team. Then going on to the uniqueness or the modifications that were done on BEDS 5 satellite. The BEDS 5 satellite, it is a unique project in that it was started in a pandemic, at the peak of a pandemic, and it was finished during the pandemic. Secondly, the BEDS 5 project is the first QTech project with 2 different configurations under one project, which is the 1U satellite and the 2U satellite. Going forward, I would like to talk more about the BEDS 5, that it is the first CubeSat to have, at QTech, to have a multispectral camera mission at Kyushu Institute of Technology. Then also it is among the BEDS satellites, it is the first to carry a number of satellites, Raspberry Pis, and it carries a maximum of 3 Raspberry Pis. Then additionally, the BEDS 5 is the first on QTech to have a satellite attitude visualization application for visualization of the satellite. And additionally, the complexity of this project is that it was built by 2 different teams, one at QTech and one at ISAS. These teams were 900 kilometers apart, and the components were made by different manufacturers and assembled at QTech. This is only for the Japanese satellite. And also, lastly, it has a new design of the passive system, which is the attitude determination and control system. So these on the slide currently is the BEDS 5 satellites, and they are meant to be deployed today. I thank you for your attention to this presentation, and I would like to welcome any questions to the audience at QTech. Any questions to the audience? Yes, Father?
Maybe Japanese.
Okay. Translate in Japanese. Okay, I think there are no questions, so thank you very much.
本日時間の都合上と、あと本日メディアの方が参加してないということで、日本語の方は預かっていただきます。続きまして、バード5の活動風景の動画ございますので、こちらの方をご覧いただきます。
And we heard there from our own Victor Mukungunugwa, who is a senior research scientist at the ZIMSAT. He was also the project manager for the ZIMSAT, the BEDS5 rather project that includes Japan, Uganda, as well as Zimbabwe. And he spoke about the launch process, the deployment process for the ZIMSAT-1 that is taking place today. He also spoke about the specifications of the ZIMSAT-1 satellite, as well as the missions that are associated with the satellite. We shall be discussing that and more here with my guest. That's Tatenda Marimo, who is a space operations and launch services engineer with the Zimbabwe National Geospatial and Space Agency, ZIMSA. Tatenda, let's recap the missions of the ZIMSAT-1 satellite that were mentioned by Victor Mukungunugwa. Perhaps a recap.
Thank you so much, Mr. Mashlasha. Let me just give you probably a brief background of what is ZIMSAT-1 and where exactly we are coming from. So ZIMSAT-1 is actually a product of ZIMSA, which is the Zimbabwe National Geospatial and Space Agency, which is a body corporate which was established under the visionary leadership of His Excellency, the President of the Republic of Zimbabwe, Comrade Dr. Edi Mnangagwa, through the Ministry of Higher and Tertiary Education, Innovation, Science and Development. And this ministry is led by Professor Dr. Amon Murwira. So when ZIMSA was established, it was given a mandate to foster the peaceful use of space and also to promote innovation research in geospatial science, earth observation, space engineering, and also foster international collaboration. As you just heard, that we're collaborating with Japan. So ZIMSAT-1 has got a number of missions, and one of the missions is land use and cover. We also look at water quality assessment and also soil fertility analysis. So on the land use and cover, Mr. Mahlahla, that is where we can be able to use our satellite, our own indigenous nano-satellite, which is ZIMSAT-1, to look at and take images on the nation of Zimbabwe, the country of Zimbabwe, and those images are then analyzed so we can be able to do what is called environmental analysis. We can see the changes that are taking place over time on the environment. So we can then be able to mitigate, and also it also addresses and also informs policy making. So that's one of the missions for ZIMSAT-1. And also we are able to use ZIMSAT-1 in collaboration with what we call ground sensor terminals. So these ground sensor terminals can be used to collaborate with regards to the issues of meteorology. That is weather elements. We can be able to monitor the weather elements, and then that information or data is then relayed to the satellite, which then would downlink the data or information via our ground station at Mazoe. So in brief, generally, that is what ZIMSAT-1 is all about.
There are also issues to do with disaster preparedness. How does that ZIMSAT-1 satellite assist?
Yes, of course. ZIMSAT-1 is also going to assist the nation in terms of disaster mitigation and management. So with ZIMSAT-1, we'll be able to monitor maybe issues like cyclones. We can be able to monitor landslides so that we can give a warning or early warnings to our citizens before disaster strikes. So this is what we'll be able to do and achieve with ZIMSAT-1.
So our viewers would want to know what exactly is different from what happened on the 7th of November 2022, the launch into the International Space Station, and what is taking place now in Fukuoka, Japan, the deployment of the nano satellite. What are the differences?
Oh, thank you very much. That's a very good question and a very good observation. Now, what happened on the 7th of November 2022? ZIMSAT-1 was actually launched into space. And maybe let me just take you back a little bit so that we understand what really happens on the process of satellite development, and then we then take you through the launch process. So now, before a satellite is actually developed, the satellite team or engineers have to sit down and clarify the mission or define the mission. What exactly are we supposed to do with this satellite? What is its use? So we don't just design and develop a satellite for just designing. It's not an accident. So but
you are saying satellites are actually mission specific?
Oh, exactly. They are mission specific. So they are designed, and the mission is defined, and then after the mission has been defined, we then move on to the technical aspect, where the system is then designed. And we heard from engineer Victor Mkungunugwa, who is the project manager for the BIRDS 5 project. He even took us through the steps and showed us that it actually constitutes of various subsystems, and the telemetry tracking and command subsystems, transponder, antenna subsystems. So those systems then are actually developed separately and then integrated. And at every stage in time, they actually undergo some robust and vigorous testing. And after they've been joined together, those components then constitute a total system or satellite system. And that system is then taken into an environment which mimics the environment of space, so that it will not be able, it will be able to go through whatever is there in space.
Before you move on, this environment that mimics the space environment, we have that here in Zimbabwe. Was it created by you as engineers, or you had actually to take the satellite sample, so to speak, or prototype to other countries for testing? Like
what has been mentioned earlier on, the project for the development of ZIMSAT-1 was done by Zimbabwean engineers in collaboration with the Kyushu Institute of Technology in Japan.
Okay.
So the test facilities are in Japan.
Okay.
Yes.
Okay. You can move on.
Right. So after the flight model has been developed, it is going to go through tests, and then after those tests have been completed, that model or that actual flight model is then taken for launch. So in this case, that is what happened on the 7th of November 2022. Our ZIMSAT-1 was taken into a rocket, the Cygnus rocket, and then it was taken into space. So that process of actually transferring or lifting the satellite from the ground or from the Earth into space, and in this case, ZIMSAT-1 was then taken into the International Space Station. So that is the process that happened on the 7th of November. And then today, which is a very historic moment as a nation of Zimbabwe, we are therefore witnessing the release or actual deployment of the ZIMSAT-1, which was aboard the International Space Station, ISS, into its proper final orbit. We call it parking. So now when it is now in the orbit, the ZIMSAT-1 will then be able to carry out its missions, those missions that were defined.
Okay.
Yes,
okay.
So we will be able then as engineers here in Zimbabwe, using our own ground station at Mazowe, to send commands to downlink mission data. So generally that is what we'll be able to do.
And those are the differences.
Yes, those are the differences.
Yeah,
yes.
I also want to understand, how are you able to interact with a satellite? Tell us about the movements. How will it be orbiting around Earth? Where exactly will it be positioned? At what speed? And what kind of perhaps interactions do you have with it as it moves across space?
Okay, thank you so much. I'll start by answering how we'll be able to interact with the satellite. So let me just educate us a bit. A satellite system consists of what is called a space segment and an Earth segment. So these two subsystems or segments constitute what is called a satellite system. So the Earth segment, we have what we call ground stations, right? So these ground stations are the ones that actually have antennas and communication equipment that will be able to communicate with the satellite when it passes over that ground station. So that is how we'll be able to communicate with the satellite. And of course, you have heard that we are part and parcel of the Birds 5 constellation, meaning that we'll be able to access the satellites of these other nations as they pass through Zimbabwe. So now, in terms of how the satellite is going to stay in orbit, when the satellite is in orbit, it suffers or it incurs what we call some centripetal and centrifugal forces. And of course, the Earth actually exerts a certain force, which is the gravitational force, trying to pull the satellite to Earth. But at the speed at which this satellite is going to be released today into its orbital trajectory, the satellite will be able to maintain its position.
What's that speed?
It's generally around 8 kilometers per second. So that is the speed for a satellite that is operating in the low Earth orbit.
Before you proceed, engineer, our satellite will be traveling at about 8 kilometers per second of speed. How many of those are in that kind of a space? Do they not collide? Is it an open space? Is it a vacuum where it's only the one that is flying across space?
Okay, of course, now the LEO, let me just answer the other question that you asked. You talked about the distance where it is going to be orbiting. Like I mentioned earlier on, ZIMSAT-1 is a low Earth orbit, which is LEO, meaning that that satellite is going to be traveling in an orbit which is between around 180 kilometers to 2,000 kilometers above the surface of the Earth. So that is the altitude of that satellite. And now, in terms of how many satellites are there in orbit, I can simply say that there are quite a number, thousands of them, over 2,000, that are already in orbit, that have been deployed by other Earth-faring nations. So in the case of how then do we make sure that these satellites do not actually collide, we have what is called orbital slots. So when the satellite is sent into orbit, a certain slot is identified or position where it is going to be placed. and then the satellite will start to move around in that particular slot. I mean, let me just take you through, I think you know the merry-go-rounds
Yes,
thing.
yes,
So
yes, yes.
just take it that way, that I'm sitting here, you are sitting there, and then this place starts to rotate.
We
so
don't
we
collide.
we are not going to collide. We are going to go at that particular speed, and each and every one of us achieving our own mission. So that is how ZIMSAT-1 is going to be able to achieve its own mission without colliding with other satellites that are already deployed in that low Earth orbit.
Engineer, it's very fascinating indeed. The world of science, the world of robotics, and the engineering world, that the space world that we have actually delved into. We are giving to you proceedings from Japan, where the Zimbabwean satellite, the first of its kind, the ZIMSAT-1, will be deployed into space. It was launched on the 7th of November 2022 in Virginia, the United States of America. And today in Fukuoka, Japan, that satellite will now be deployed. And as you have heard from Victor Mkungunugwa, Zimbabwe's project manager of the BED5 project, mentioning the missions that are associated with the ZIMSAT-1 and also the process leading to the deployment of the satellite today. And now we are just hearing from our engineer, who is also in charge of the space operations and launch services with the ZINSA. That's Zimbabwe's National Geospatial and Space Agency, established by the Ministry of Higher and Tertiary Education to look into issues of Zimbabwe getting into space, of course catching up with other nations. It's actually exciting, engineer, hearing what Zimbabwe is doing in space amongst the other big countries such as Japan. One question that I've heard being asked by Zimbabweans is, isn't our satellite too small? Perhaps they are used to seeing big satellites being launched into space. Explain the size of Zimbabwe's ZIMSAT-1.
All right, thank you so much. I think that is a very relevant question at this particular moment in time. I see quite a number of people are actually concerned about the size of the satellite. But let me say to you that due to the advancement in the technological development, size no longer matters nowadays. We are able to achieve specific goals and objectives using smaller objects. So in this case, ZIMSAT-1, as small as it is, as a nanosatellite or CubeSat, will be able to achieve its missions due to the advancement of the technology that is aboard that ZIMSAT-1. So the size is not a problem. What is important is the mission that ZIMSAT-1 is going to carry out.
The other issues pertaining to the size, small as it is, you said it will be traveling at about 8 kilometers per second.
Yes.
And it's got very, very powerful cameras.
Yes.
Tell us more about these cameras.
Okay, so our ZIMSAT-1 is actually carrying some multispectral cameras with it. And of course, it has got some antennas with it there. Now, these multispectral cameras will assist us in the ability to visualize and take images on the Earth as it passes through the particular points and areas that we are concerned. You heard Engineer Mkungunugwa talking about water quality assessment. So let's assume that our satellite is passing over Kariba. So those satellites, those cameras, multispectral cameras will be deployed, will be able to take images, and will be able to then analyze using the digital signal processing aboard those satellites to see how much of our water and how much do we have, and also in terms of the quality that it has. And also those cameras will be used for mapping and also looking at what is happening in the agricultural sector. We've had quite a number of times people trying to figure out how much land has been tilled, how much land is under hectarage, how much land is under wheat, how much land is under maize. But now through the use of these multispectral cameras, we can then be able to find out, quantify even the yields that we are going to get. So we are able to do that. We are also able to monitor the crop health using these multispectral cameras.
They are very, very powerful, isn't it?
Yes.
Now, you mentioned the satellite moving over Zimbabwe. How often will it be moving over Zimbabwe?
Okay. As a general principle, a LEO or a low Earth orbit satellite like the ZIMSAT-1 will have a complete orbital period that is rotating 360 degrees around the Earth every 90 minutes. So that is what will be happening. Okay. But now, as we all know that the Earth is also, as it is rotating around the sun, it is also rotating tilted on its axis. So when a satellite passes, we call it a satellite pass. When it passes, let's assume over Pockets Hill, the next time when it is going to pass, it might pass maybe over Domboshawa there in the Shumba or Marimo area there. And then the next pass will take place somewhere there, maybe in Mutare. But while it is passing over that side, because of the swath or the area of coverage that the satellite is able to beam, we can then be able to still send and receive commands. So that is how the satellite will be able to go around the Earth and also over Zimbabwe.
Engineer, the other exciting development with regards to the coming in of the ZIMSA is the opportunities that are available even for Zimbabwean engineering students. Tell us about the career prospects for students in Zimbabwe who might be excited right now as they are watching you talk about the satellites, the launches, the space issues, the work that we have done so far. What hope is there for them, and what kind of perhaps courses should they take if they want to be part of the ZIMSA?
Oh yes, there are quite a number of opportunities that are open. Like I mentioned some time when you started the interview, that is ZIMSA is mandated to foster research in geospatial science, Earth observation, space engineering, space science, navigation, communications engineering, space physics. So these are a number of areas that the students in Zimbabwe that are undergoing STEM-related education can actually venture into. But allow me also to say that ZIMSA is a bigger tent, in the words of His Excellency, that leaving no one and no place behind. So we are saying that at ZIMSA are over and above taking in those students or those individuals that have got technical and engineering background. We also have the accountants coming in, administration. So generally anyone can be part and parcel of a space agency. So in terms of the technical side, we are, like I mentioned, we have got electrical engineering, aeronautical engineering, aerospace engineering, mechatronics, we've got telecommunications, we've got space science, those people that are taking weather-related studies, quite a number, and also remote sensing. So these are the type of areas that one has to look at when you consider coming into ZIMSA for technical opportunities.
Of course, it also implies that the future is techno-based. And I believe the coming in of satellites will actually make the future even easier for countries like Zimbabwe, which have also been facing challenges of climate change, droughts, floods, cyclones, for example. And this ZIMSAT-1 is actually handy in terms of prediction of those disasters. Tell us more about that aspect.
Okay, thank you so much. You rightfully mentioned that the environment that we are living in is now more like a VUCA environment, which is volatile, unpredictable, dynamic, and etc. So in terms of being able to adapt, we need to move fast, to move with speed. So in terms of our technology at ZIMSA, we will be able to do what is called disaster mitigation in the issues of satellite, with regards to the issues of weather disasters. Our satellite cameras will be able to map and then send the imagery. Those images then are then going to be analyzed, and we can be able to see maybe a cyclone when it is forming. And when the cyclone is passing, we are able even to determine its speed, where it is coming from. And then we can then be able to alert the relevant authorities so that our people can be saved from such disasters. And also in conjunction with what I mentioned earlier on is ground sensor terminals and also weather stations dotted around the country. Those will be able to send the information via the satellite. Mind you, for the meantime, we have some challenges whereby maybe these ground sensor terminals or weather stations are sending the information maybe via GSM. What happens in the event of a catastrophic disaster when infrastructure is broken down? So that is when we then have to look up to the heavens for the help that is going to come via our satellites.
Wow, it's symbolic indeed, looking up to the heavens for help. You have also mentioned that this satellite, the ZIMSAT-1, has been deployed from the International Space Station. Tell us more about the International Space Station. Which other projects are happening there? What kind of a station is it? What kind of ships land on the International Space Station, and what happens there?
Okay, thank you so much. Now, the International Space Station is actually a space, we can call it a satellite, because by definition, a satellite is any object that revolves another bigger object in space.
Okay.
So we even have two kinds of satellites. We've got what is called natural satellite. So the moon is actually a satellite.
Oh, okay.
Yes, and then this International Space Station is what we call an artificial satellite. And also our ZIMSAT-1 is an artificial satellite. Now, in terms of what happens, or what is the International Space Station, it was actually developed by a number of nations. United States of America, Japan is also part and parcel of that, and Europe has also some shares on that one. So what how they came up with that is that they were joining modules together. Those modules were joined and then formed the International Space Station. It covers an area that is as large as a football pitch. That is how big it is. So we had collaboration with Japan, and for us, our satellite ZIMSAT-1 is deployed via what is called the Kibo module, which is a module that is owned by Japan. So a number of scientific research is actually taking place in the International Space Station. We have got scientists here taking maybe certain crops into space to find out how they are going to fare in space, how they will be able to grow in space where there is no gravity. So by so doing, probably we might come up with a new kind of crops that are resilient and that can be able even to bring better yields. So these are some of the projects, scientific projects, that take place in space.
Wow, we have also heard about Elon Musk's vision or desire rather to actually take people to space to live there. Is that practical?
Oh, of course. You know, whatever you vision or whatever you desire to do, you can get it. I think even the Bible says that. So that is very, very practical, but it just needs people to work even harder, because it has been demonstrated by the evidence of scientists that are aboard the International Space Station. They are there almost for a period of a minimum of 6 months in space.
So how long can one live in space? How long for?
So for the record, I understand, I think the first human being to stay for quite a long time, I think that was almost like a year. That is an American, I've forgotten the name, but generally they normally have shifts where, you know, scientists just go into space and carry out their experiments for a period of about 6 months, and then they come back to Earth, and then another team goes back to space. Wow. Yes, so that is what has been happening. Obviously, they won't see the space station unmanned. Probably if we are 6 here, 3 of us will go, and then the other 3 will come in, and then there will be that kind of exchange. So that is how it is happening in space.
And it looks like that interaction between Earth and space is actually getting more and more by the day. And Zimbabwe just joining the number of countries that have been sending satellites into space, and today the launch, the deployment rather, of Zimbabwe's first satellite, the ZIMSAT-1, into space, as we are hearing here from Tatenda Marimo, a space operations and launch services engineer with the Zimbabwe National Geospatial and Space Agency. Earlier on, we heard and also saw events that are taking place in Fukuoka, that's in Japan, where Victor Mkungunugwa, the project manager of the BIRDS 5 project that includes Japan, Zimbabwe and Uganda, telling us more about the deployment of the ZIMSAT-1. Let's also watch this BIRDS 1 update shortly. welcome back, and of course we also want to welcome our viewers who have joined us on the ZBC News 24 channel, on our Facebook page ZBC News Online. This is live coverage of the deployment of Zimbabwe's satellite, the ZIMSAT-1, into space, taking place today in Fukuoka, Japan. And we know that the ZIMSAT-1 satellite was successfully launched into the International Space Station on the 7th of November 2022 in Virginia, the United States of America. And today, the big day, as the satellite will be deployed into space to begin its functions and its missions. 5 missions that have been specified there, including the issues of weather predictions, disaster predictions and mitigation, to do with land mapping, to do with analyzing the quality of water resources, even also the country's forests and other functions that are associated with the 5 missions there. So I'm joined in the studio by engineer Tatenda Marimo, who is a space operations and launch services engineer with the Zimbabwe National Geospatial and Space Agency. And we have been giving you proceedings from Fukuoka, Japan. Let's actually join our guys there in Japan to find out what is taking place now.
This is Jackson Franklin. We would like to ask your final goal for satellite deployment of launcher 1, representative of South African SAT-1 of Ghana. Are you ready?
ZIMSAT-1, we are ready. Go! Woo!
We would like to ask a final goal for satellite deployment from launcher 1, a representative of Taka from Japan. Are you ready?
Okay. This is the Taka team. We are ready. Go!
Scorpio, the deployment will be on time. This is JAXA Flight Director. We would like to ask your final goal for satellite deployment from launcher 1, the representative of ZIMSAT-1 from Zimbabwe. Are you ready?
ZIMSAT-1 team, we are ready. Go.
Copy. The deployment will be on time. This is JAXA Flight Director. We would like to ask your final goal for satellite deployment from launcher 1, the representative of Space Tuna 1 from Japan. Are you ready?
This is the Space Tuna Team 1 team. We are ready. Go!
Scorpio, the deployment will be on time.
So the ZIMSAT-1 has been released into space. The successful deployment of Zimbabwe's first satellite there on your screens. It's been released successfully in Fukuoka in Japan, and I'm sure you also witnessed it was a slightly bigger object, implying that it was actually combined with the Japanese Taka satellite that has also been released today. Earlier, we saw the engineers checking with Zimbabwe's representatives. We heard there from Mr. Pinos Ngweme, the Director General of ZIMSA, who actually gave the thumbs up and said, we are ready as Zimbabwe. And yes, the launch and the deployment have both been successful. The launch on the 7th of November 2022, and today the deployment of the satellite into space. Again, a success for Zimbabwe, a success for the sons and daughters of Zimbabwe who have worked tirelessly on the project, the ZIMSAT-1 project and the BIRDS-5 project combined there with collaborations, of course, from the government and the people of Japan. It's been a success. The satellite, the ZIMSAT-1, has been launched. Engineer, it's a success story, isn't it? And it's good news for you. I'm sure you're happy.
Yes, that's a very good success story. I'm actually happy that we've done it, and I'm sure we are going to do it again.
Yeah.
Yes.
You'll do it again. So
Yeah,
tell us what has been happening before we saw the countdown. What exactly was happening in terms of perhaps the safety of the satellite and the preparations? What was taking place?
Okay, just before the satellites were released into orbit, before the go command was given, there is a countdown that takes place. I'm sure you remember that we were supposed to launch on the 6th the other time,
yes.
and then we launched on the 7th.
Yeah.
So it is very, very necessary because the safety is of utmost importance. So we have to make sure that everything goes according to plan. So during the countdown, they will be analyzing to find out if there are any issues that might arise in the deployment. If there is something that would happen or arise, they can then stop the deployment, just like what happened when the launching was
on the 6th of November.
Yes, on the 6th of November. So when the countdown completes, then the satellite is released into orbit. So basically, that is what was actually happening.
And of course, Zimbabweans now want to know, the satellite has just been deployed. When do we expect to start to get information and data from ZIMSAT-1?
Oh yes, obviously when someone is finished cooking SATSA, the next thing is you want to know when are we going to start eating.
Definitely.
Yes, so generally for ZIMSAT-1 and also all CubeSats, once the satellite has been deployed into orbit, it will be going at a certain speed, and obviously we need or require it to stabilize before we then start to send some commands to it.
Is this what we are looking at right now on the screen? Is that the stabilization process, or is still part of the deployment process?
Of course, what we are looking at the screen for the meantime is we are seeing images, I'm sure, from the International Space Station.
Yes.
So we are just seeing how the satellite is orbiting, moving around the Earth. So obviously, it is still a bit unstable, but when times go on, it is going to stabilize, and then when it does that, we then will be able to then send commands and then also then obtain our mission data, like we earlier on explained.
People also want to know, what kind of commands are you talking about? What commands are those?
In terms of commands, it's just a simple go command. Just like you are saying, okay, we want to do something, we want to activate this machine or this keyboard module. So in terms of how our satellite was launched, I mentioned earlier on that it was via the Japanese keyboard module.
Yeah.
So obviously it's some kind of electromechanical part or component which will then have to release the satellites into orbit. So someone has to send a command, just to press some launch button that then initiates the whole process to take place. So basically, that is what happened. And of course, you saw there our own Director General, Mr. Pinos Ngweme, giving the command for ZIMSAT-1 to go, meaning that everything was in order, and then the process then initiated, and the satellite was actually then released into orbit.
And of course, yes, the satellite successfully released into orbit, also signifying that Zimbabwe has finally joined the international space stations and those space-faring countries, courtesy of the BIRDS 5 project by the government of Japan, to ensure that non-space-faring countries such as Zimbabwe, such as Uganda and others are also part of what other countries are doing with regards working in space and benefiting from the use of space technology such as satellites. And Zimbabwe's ZIMSAT-1 satellite has been successfully launched. You are seeing there the pictures just after the launch, and we saw also the countdown to the successful launch of the ZIMSAT-1 into space. Those are some of the images that are coming from the International Space Station, confirming the success of the launch of Zimbabwe's satellite into space. So we can safely say the launch has been successful, the launch has been done, and as you said, if we have done it, we can do it again. What do you think are the future prospects for the space engineering industry in Zimbabwe? Engineering.
Oh, thank you. Yeah, indeed, the process for releasing the satellite into orbit has been a success, as we were all able to witness. And obviously, for the future of engineers that are going to look at space-related issues, the future is very, very bright. Because this is just a stepping stone, or just a starting point as we join the League of Space-Faring Nations as Zimbabwe. So that is
what you can also just... Oh, yes, that was... Wow. Okay, that was the confirmation that Zimbabwe is ready.
Final goal for satellite deployment from Launcher 1, representative of Taka from Japan. Are you ready?
Taka team, we are ready. Go!
Tokyo, the deployment will be
a replay there of the deployment as it happened earlier, and that was from Zimbabwe as well as Japan, the Zimbabwean satellite ZIMSAT-1 and the Japanese satellite, the Taka, both being released into orbit today. And that's Mr. Painos Weme, the Director General of the Zimbabwe National Geospatial and Space Agency, giving the go-ahead and the thumbs up for Zimbabwe's readiness for the ZIMSAT-1 to be released into space. You were talking about the way that Zimbabwe is now getting ready to share the space with other spacefaring countries. You can proceed, engineer.
Thank you so much. So we are saying that as Zimbabwe, we are saying the future is bright for all those individuals that are interested in joining space-related technology and applications. So like we mentioned that ZIMSA was mandated to actually foster the development of geospatial science, space engineering. So it means there is now an opening for such. And of course, there's going to be a cascading effect of value chain industries that can actually be developed from the deployment of ZIMSAT-1 and of course from all the other projects that ZIMSA is going to carry out. So I see the future is very, very bright. And of course with the space science and technology, allow me to say that it was actually long overdue for us to venture into space. Why? Because we have been trying to tackle the problems that we've been facing here on Earth using the same old and tired methods of doing things. But now when we now take things into space, it means we're now having a different perspective and a different approach. We have got an overview of what is really happening, and then we can then be able to inform policy. We can then be able even to do a number of activities, applications, like even being able to map minerals resources in our country. Yeah, it's very possible using that satellite technology, imaging, mapping, and even quantifying the amount of minerals that we have.
And the satellite can do the quantification of minerals?
Yes, the technology that is aboard that satellite is able to do that. It is able to do that.
And like engineer, you are now actually boggling my mind. Our Zimbabwean engineers are able to produce such kind of technology. We are talking of our, for example, our own Timothy Kuhamba, who was part of our engineers here at the national broadcaster. He's part of the team that worked on the BIRDS 5 project.
Oh yes, you know, some of the engineers.
Perhaps let's follow the proceedings there from Japan, where we are now hearing congratulatory messages.
The deployment of Uganda's first satellite into orbit. we have just witnessed a historic moment for Uganda's space program. First of all, I would like to extend my sincere congratulations to the people of Uganda, especially to the team from the Ministry of Science, Technology, and Innovation. I would also like to mention the important role played by the Japan Aerospace Exploration Agency, JAXA, and the Kyushu Institute of Technology, known as QTech, in the technical support and cooperation for the Pearl Africa Sat-1 satellite. I am very pleased with the fact that Japan was the place where Ugandan engineers were trained in the design, building, testing, launching, and operation of the satellite. This event represents a great partnership between Japan and Uganda in the field of innovation. I hope that satellite technology will help to enhance Uganda's development in areas such as weather forecasting, disaster prevention, and agriculture monitoring, among others. As far as I know, this satellite initiative was sparked by the visit of the Ugandan delegation led by President Museveni to Japan for the 2019 Tokyo International Conference on Africa Development. It is my hope that Japan and Uganda will enjoy a fruitful partnership for many years to come, and that this milestone will lead to many successful projects and achievements. Thank you.
Ministers, ambassadors, distinguished guests, and ladies and gentlemen, Mangwanani from Harare. Today we celebrate the wonderful outcome of people-to-people exchange between Japan and Zimbabwe. Zimbabwe's first satellite was launched into space on the 7th November from a NASA launch pad in Virginia, USA. Causing a lot of excitement here. It was developed by Zimbabwean students studying at Kyushu Institute of Technology in Japan through the BIRDS program. The goal of the program is to share space technology with non-space countries. It is no mean feat that through many hours designing it and testing it, Zimbabwean students finally developed their own satellite, so that the Zimbabwe has been launched into the space age. Like any other technology, space technology is just a tool, and the important thing is how we use it. By taking photos of the country's land, satellites can be useful, such as enabling us to monitor climate change, prevent environmental degradation, and give early warning of disasters. Japan has a lot to share in terms of the latest technology, and I'm glad that the students could greatly benefit from learning about the space technologies. I look forward to further advancement in Zimbabwe's space technology for the benefit of the country and the future generations. Once again, congratulations, Makoro Koto.
Today is a very special day that we have witnessed the deployment of the very first satellites Uganda has received. On behalf of the government of Uganda and my own behalf, I want to take this opportunity to congratulate the government of Uganda. I congratulate His Excellency, the President of the Republic of Uganda, Yoweri Kaguta Museveni, the people of Uganda, to take the institute that developed this technology, JEXA, and the work they have done, and also the students that developed the first satellite. This is great, And Uganda has had now the first step in the space. This is the beginning. We hope to explore more in space. I want to thank the government of Japan for the good relationship we have had, and for the science technology. We shall move more to work together for more technology to develop the world. Technology is the way to go. I thank everybody. I thank you, Tech. I thank Jakisa, all of you. Thank you so much. May God bless you.
I would want to take this opportunity to thank the government of Zimbabwe, and in particular the President of the Republic of Zimbabwe, for giving us this opportunity to participate in such an international research cooperative cooperation. We have started a journey, and I want to assure fellow Zimbabweans that this is the beginning of a long journey. We are going to explore more beyond the solar system. I also want to take this opportunity to thank the government of Japan, and in particular JAXA, for the cooperation and the friendly environment, and also Kyushu Institute of Technology for our engineers who have graduated and you have developed the much needed capacity for our country. And as a country, we are going to do much more at home using this space science technology that you have awarded to us. Thank you very much once again. Thank you very much once again.
I would like to thank, first let me begin by congratulating Uganda. Congratulations, Uganda! I would like to thank the government of Japan. Thank you so much for the support. Thank you, the Kyushu Institute. Thank you for the institute which trained our engineers. Thank you very much for the support and bringing us this far. I want to congratulate our students, our engineers now graduated. I want to congratulate and thank the Embassy of Japan for your support. And I want to thank, above all, I want to thank the President of Uganda, Yoweri Kaguta Museveni, for his unwavering support for science, technology, and innovation for our country. Congratulations, Uganda. Congratulations. I'm here with the Committee of Parliament, which is in charge. Congratulations, honorable members, for your support. Thank you very much.
It is with great joy that we congratulate Zimbabwe on this historic landmark launch of ZIMSAT-1 and its successful deployment into orbit. ZIMSAT-1 program is a government of Zimbabwe program implemented through a cooperative research agreement on BIRDS 5 entered between the Zimbabwe National Geospatial and Space Agency ZINSA and the Kyushu Institute of Technology QTech in Japan. The success of the BIRDS 5 program was made through the support of the Japanese Aerospace Exploration Agency JAXA and the National Aeronautics and Space Administration NASA. ZIMSAT-1 is primarily an Earth observation and data transmission satellite that will be used in the areas of agriculture, environmental management, and meteorology. We would like to thank His Excellency the President of the Republic of Zimbabwe, Dr. Edi Mnangagwa, who provided all the required support, the entire ZINSA staff, engineers in Japan and those in Zimbabwe, and other agencies in Zimbabwe. This achievement is worth all the attention, and as the government of Zimbabwe, we will continue supporting the development of advanced scientific missions that will enhance innovation through space science and technology. Congratulations, Amhlope Makorokoto.
Please forgive me to use on the Japanese. バーズ5衛星3機が無事に国際宇宙ステーションに放出されました。九州工業大学を代表して学長の三谷より挨拶をさせていただきます。はじめに九州工業大学関係者並びにジンバブエ、ウガンダの関係者にお祝い申し上げます。バーズプロジェクトは大学院の宇宙工学国際コースを中心に行われている日本と海外の共同プロジェクトによるグローバルエンジニアを育成するプログラムです。今回のプロジェクトは2020年夏から開始し、終始コロナ禍での開発となりましたが、ジンバブエ、ウガンダ両国初の衛星開発を完了し、無事に軌道上に放出することができました。大変喜ばしく感じております。また、本学の高衛星は、JAXA の宇宙科学技術研究所との共同開発も行い、宇宙科学のミッションに取り組みます。九州工業大学では引き続きこのような国際プロジェクトを推進し、宇宙開発の裾野の拡大を目指していきます。最後になりますが、ジンバブエ、ウガンダや JAXA の並びにさまざまな関係の方々にご支援の感謝を申し上げます。私からのご挨拶をさせていただきます。Thank you very much.
Congratulations to the successful deployment of the four CubeSats, Pearl Africa Sat-1, ZIMSAT-1, TACA, and Space Tuner 1. I'm glad and honored to take part in this moment, and I also believe that this deployment has given a lot of courage and hope to the students of the universities and young engineers in Uganda, Zimbabwe, and Japan. It is our pleasure to support these important missions in cooperation with BIRDS 5 project by Kyushu Institute of Technology, and I would like to express my sincere respect to the members of each project team for their great achievement. Space activity is an exciting endeavor with infinite possibilities. JAXA always welcomes the young generations involved in this kind of missions to join in the fascinating challenge in space. We look forward to the future opportunities to work together with you for promoting space activities for humanity and sustainable world. Thank you very much. Congratulations.
Hi, Pan-Africa ZIMSAT-1 team from Uganda, ZIMSAT-1 team from Zimbabwe, and TACA team from QTech. We are the JSO team from Kibo Utilization Center. I am Shinobu Doi, manager for the satellite deployment mission from Kibo. We completed the successful deployment of BUZZ-5. We are pleased to announce to you that we are going to send you the certificate of deployment. We wish you the best of luck with the success of your mission. Congratulations. Yay! Space Tuna 1関係者の皆様、JAXA 希望量センター JSOD チーム主幹の土井です。今回無事に衛星放出が完了いたしました。希望量センターよりこちらの放出証明書を皆様のもとにお届けいたします。皆様のミッションの成功をお祈り申し上げます。おめでとうございました。
This is JAXA Flight Director. We would like to ask your final goal for satellite deployment from Launcher 1, a representative of Pan-Africa ZIMSAT-1 from Uganda. Are you ready?
ZIMSAT-1, we are ready. Go! Woo!
We would like to ask a final goal for satellite deployment from Launcher 1, a representative.
Yes, and Zimbabwe has been ready. It was ready, and the launch was successful today, as well as the deployment, so to speak, of the ZIMSAT-1 satellite into space. As we have heard from our guests, we are now waiting also to start downloading the data from the satellite that is now in orbit after it would have stabilized. But we have heard also and witnessed the congratulatory messages coming in following the successful deployment of the satellite into orbit. We heard from representatives of the Ugandan government, representatives of the Japanese government, and also that's Mr. Satoshi Tanaka, Japan's ambassador to Zimbabwe, congratulating Zimbabwe, and also heard from our own Minister of Higher and Tertiary Education, Innovation, Science and Technology Development, Professor Amon Murwira, representing the Zimbabwean government and congratulating the government for the successful launch of the ZIMSAT ZIMSAT-1 satellite into space. So later on, we shall be hearing concluding remarks from Professor Cho, who also addressed the world at the beginning of the deployment program today. But I still have in the studio our guest, that's Tatenda Marimo, who is a space operations and launch services engineer with the Zimbabwe National Geospatial and Space Agency. Engineer, we can safely also say it's been mission successful. This is where those words really come into play, isn't it?
Oh yes, we can say that, but we are still going to be able to then actually get the information or the data that is going to be relayed for all the missions that we've talked about. We've got the store and forward mission. I think maybe we might not have touched much on that one. We are also going to get some information or some data from that, whereby we've got sensors that are dotted across the country that will be able to relay some information to the satellite. And then that information is then stored in that satellite and then released to our ground station at Masowe. So these are some of the missions that ZIMSAT-1 is going to be able to accomplish in the long run as we are going to operate the satellite. Yes.
You are part of a group of Zimbabwean students who have been working on this project from inception up to today. And let's look at what have the Zimbabwean students in Japan, for example, gained from their interactions with their Japanese counterparts?
Thank you very much, Mr. Mahlahla. Maybe a point of correction. We are not really students in court, but we are engineers that have qualified. But of course, education does not stop when we have a certain qualification. So they are continually improving themselves.
Let's cross over to Professor Cho.
Let's one point and until the end. Again, congratulations. And this was a really good moment, and you did very well. Thank you.
Thank you. 本日はバード5衛星の ISS 放出パブリックビューイングへお集まりいただき誠にありがとうございました。最後に記念撮影を行い終了となります。このイベント後の衛星運用は夕方6時55分を予定しております。それでは皆様ありがとうございました。
Okay.
That's Timothy.
Coming in, pouring in for the Zimbabwean team there that you see Victor Mukunungu Gwai, also see Timothy Kuhamba, who are part of the team that worked with the Japanese in the development of the BIRDS 5 project, and of course the ZIMSAT-1 satellite that we witnessed being launched and deployed into space today. And a success indeed, and a success story for the Zimbabwean engineers, a success story for the Zimbabwean government as it also tries to leapfrog its own development, joining the League of Nations who have been exploring space for years. And yes, Zimbabwe starting its own space journey today as it joins other countries there. Uganda also being part of that journey, as well as Japan, of course, being the seniors in that group, showing Zimbabwe and Uganda the way in terms of how to be part of the space world, the Space League, and also benefiting from the use of technologies that include satellites and robotics. Yes, engineer, you were talking about the benefits accruing in terms of skills exchange between Zimbabwean engineers and their Japanese counterparts. What are we expecting?
Yes, of course. Apart from successfully launching our own ZIMSAT-1 and also releasing it, deploying it today into orbit, the group of engineers that are resident in Japan, you mentioned rightfully, we've got Victor Mkungunugwa, we've got Ramson Nyamkondiwa, we've got the Timothy Kuhamba. They managed to develop or obtain technical and educational skills that they are going to bring back into Zimbabwe so that they can impart to other engineers that are back home. So we are sure that those skills are going to go a long way in improving the status quo of the space-related skills that are in Zimbabwe.
Yes, there is the photo shoot. You see the team that was involved today in the successful deployment of the ZIMSAT-1 satellite. It's a jovial atmosphere. It's indeed a triumphant moment for Zimbabwe, for its engineers, a triumphant moment for the country. As we also leave you watching those pictures there, we want to thank you so much for having joined us and for having been part of this discussion, a live coverage of the deployment of the ZIMSAT-1 satellite into space, a project that was carried out between the government of Zimbabwe as well as the government of Japan. But it's a part of the bigger BEDS 5 project where Japan has been assisting non-space-faring countries to also become part of space-faring countries. Now, as we await to see the benefits of the deployment of that satellite, we also want to remind you that this is a part of Zimbabwe's efforts to ensure that it continues to interact with the international community. It continues also to develop its own science and technology sector, as you heard from the Minister of Higher and Tertiary Education, Innovation, Science and Technology Development, Professor Emon Murgwira, pledging government support to efforts that are always on the ground to improve Zimbabwe's science and technology sector. And I want to say thank you very much to Mr. Tatenda Marimo, who is our space operations and launch services engineer with the Zimbabwe National Geospatial and Space Agency. Thank you so much for having part of this live broadcast. My name is Justin Matlatla. We meet on other programs. Bye-bye.
Thank you.